Welcome. We're going to review some topics with polynomials and factoring, things that will prove very important as we continue through the course or go through this whole year. What I'm picking out here is reminders or issues that people sometimes have forgetfulness about, I guess, or forget about. So let's start off here with subtracting polynomials. The issue here is when you have subtracting an entire polynomial. People tend to forget that that negative sign affects this to make it negative 3x squared, but it also affects this to make it positive 10x, and it affects this to make it negative 5. So what we actually have is 5x squared plus 3x minus 7 minus 3x squared plus 10x minus 5. So the key issue here is that these two terms, the minus becomes a plus, the plus becomes a minus. This one here, everyone tends to be used to because it's just minus that. But the other ones, people tend to make mistakes. So of course that means we'll have 5x squared take away 3x squared, so we have a 2x squared. And then we have 3x plus 10x, so that's 13x. And then we have negative 7 minus 5 to make negative 12. Now, there is another way to look at this, too. And that is, if I do the 5x squared plus 3x minus 7, let's rewrite it and go through it. Another way to look at it is to think of it as the 5x squared minus the 3x squared, and then the 3x, and recognize that it's subtracting the negative 10x, and then the negative 7 plus the 5. So here we still get the 2x squared. Here, these two negatives become positive, so we still get the 13x. And here, now this is where, inadvertently, I'm showing that I didn't subtract it. We have negative 7 subtract a positive 5. So what I should have written was negative 7 subtract the positive 5, either in parentheses or just put minus 5. Then I would have gotten the negative 12. So we get the same 2x squared plus 13x minus 12 that we did the other way. Both of these methods are, of course, perfectly fine depending upon your personal preference as long as you get it right. But be careful with the negatives, and as I showed with that problem, it's really easy to get a little off on it, so watch them carefully. And that's the biggest issue when having or subtracting polynomials, is watching for that negative when you have parentheses. One way to think of it, of course, is to think of it as a negative 1 times them, and that's what I tend to do myself on this other problem. Now, taking out a common factor. In this kind of a case, you are looking for everything that is common to each of the three things. So what I see here is I see that every one of them has an x. So the method I like to use is I put this underneath it so that I could sort of cross out in my mind or reduce them once I figure out the common factor. The first one is always supposed to be positive, so I'm going to take at least a negative 1 out. So for the idea of having the common factor is what you leave. Our goal is to get something out in front that multiplies to each one, but the first term inside should be a positive. So that means I'm going to take this negative out. And then I look at 6, 21, and 9, and it looks like a 3 is common to each one of them. But because I'm doing a negative here, I have to do the negative for each of them. So what that means is that my common factor will be the negative 3x, and I have to divide each of these by those. So that negative goes away, 3 goes into 6 twice, and 1x is taken away. On the next one here, the negatives will cancel. 3 goes into 21 7 times, and one of the x's from the top is canceled by the x on the bottom. So we get a 7x squared. And here it's a plus and a minus, so that means it'll be negative. 3 goes into 9 3 times, and the x's cancel out. So in this case, we get negative 3x, and then in parentheses, 2x cubed plus 7x squared minus 3. So notice in this case, I actually removed 3 different things. A negative, so that the first term would remain positive, or would become positive. a 3 for the numbers and an x for the variables. It's not always true that you're going to have all of them, of course. It's just whatever the problem shows you, and you take advantage of those. Now let's talk about trinomial factoring. When a is equal to 1, this is relatively easy for most people. Once you get the concept down, this makes a good deal of sense. If it can be factored, it can be factored this way because the first two terms must be x's. That's the only way to get x squared. The two terms that are here have to multiply to make 20 and have to add to get 9. So remember that we call these, a is the coefficient here, which is a 1 right now. B is the coefficient of the x, and c is the constant at the end. So you're multiplying to make c, and you're adding to make b. And the best way conceptually to do this is take all the numbers that what you're going to multiply to and write down all those factors, 20 and 1, 10 and 2, 4 and 5, or 5 and 4. And then which of these will add up to the 9? And that does indeed help because we can see 4 and 5 are the answers. So we can put a 4 and 5, and they're both positive. And it really doesn't matter what the order is for those. Now, let's go over to B here. And we have the same numbers, except now the 9 is negative. But we're going to do the same setup. We're going to have x's here, and we're going to have 20. But what we have to do is to get the positive 20 using, adding to a negative 9. Well, that means that both of the numbers are going to have to be negative. And in this case, if we do negative 5 and negative 4, we get a positive 20, but they add up to a negative 9. So here it's a matter of paying close attention to what the result is when you put negatives in different places. And the negative 9 is your indication that at least one has to be negative. And the positive 20 means that both have to be negative because they have to multiply to make that. Now in C, we have both things negative. So let's take a look at what that means. Again, we're going to have an x here, and we're going to have an x here. And now we want to see what makes a negative 20. Well, it's still a 20 and 1, and one of them would be negative. It's still a 10 and 2, and one would be negative. And it's still a 5 and 4, and one would be negative. But we need to add up to a negative 1. And that can only be done in this case. If we have a negative 5 plus 4, we get a negative 1. And if you multiply them, you get a negative 20. So that means we have minus 5 and plus 4. And of course, for each of these, if you multiply them out, you will get the original problem. So the last one, let's take a look at that. And notice that in this case, both are positive. In this case, the B is negative. In this case, the B and C are negative. Now we have the C being negative. So we're covering all of the possibilities here. Well, we're still going to use the same basic method, which is x and x. And so at negative 20, well, I have 20 and 1, and one of them would be negative. 10 and 2, one would be negative. 5 and 4, one would be negative, but we need to add up to make a positive 1. And in this case, the 4 would be negative, and that would give us a positive 1 if we add them. So we're going to do x plus 5 and x minus 4. A reminder that there are multiple methods of this. And one common one that I'm sort of modeling here, but not exactly the same, is if you use the diamond method, here you put the C and here you put the B, so that you're going to multiply that. And some people put it opposite way on the bottom or top. But I'm going to need a negative 20 and I'm going to need a positive 1. So it's still the same concept of looking at which factors would go there until you put 5 and negative 4. And those would multiply to make the negative 20, and they would add to make the positive 1. It's the same thing as way of handwriting it there, or it's doing the diamond method, and there's also a box method. Any which way that works is fine as long as you show how you do it. Now, this method is going to become more useful in the next part of factoring, and in particular when a is not equal to 1. So let's take a look at what happens here. I do know that in this case, the only way that I can get 2x squared is if I have a 2x and an x here. But These two numbers will multiply 1, but they won't add to 3 because this 2 complicates things. So what I want to show here is using this diamond method. And so on the top, it's going to be a times c. So we're going to multiply to get what is a times c, which is 2 times 1. And on the bottom, it's going to be b. We're going to add to get the number 3. So we need two numbers that multiply to 2, like 2 and 1, and that will add to 3. So that's relatively easy in this case, 2 and 1. They will multiply to 2, and they will add up to 3. So, oh, no, they won't. They will add up to 3. So actually, I need to change it here. 1. Yeah, no, it's 2 and 1. I've got my ticking off here, but now I'll fix it. So now what we'll do is we'll put a 2 in place and a 1 in place. So if I put the 2 here and the 1 here, oh, what I forgot, I need to go back. So watch out something here. When you do this method, with the 2's, with the number here, you actually have to put the 2x in twice. Notice that. Okay, very vital that you put it in both times. So now I will put the plus 2 and the plus 1 that comes from here. Okay. What happens next is that I look at this and I see that I can reduce this one. So if I divide them both by 2, I get an x plus 1. And here I get a 2x plus 1. And that would be the answer. And I'm going to verify it over here by multiplying it out. X times 2x gives me a 2x squared. X times 1 is plus x. And 1 times 2x is plus 2x. And 1 times 1 is 1. So we get 2x squared plus 3x plus 1. Okay, so that's what we had originally, which means this is the correct factorization for it. Let's do this with a harder problem. Sometimes the smaller numbers are actually more confusing than the harder ones. Let's look at the bigger numbers. So let's look at this one with 24x squared minus 10x minus 1. So in my setup for factoring it out, I'm going to put the 24 twice. That's the key thing that I need to make sure I emphasize here for that, since I forgot it at first in the last problem. And then I'm going to make the diamond, and this is going to be a times c, which is 24 times negative 1. And then the b down here, which is negative 10. So it'll add to the negative 10 and multiply to the negative 24. So all the factors of negative 24 are 24 and 1, and 1's going to be negative, 12 and 2, 6 and 4, and 1's going to be negative. Ooh, I forgot 8 and 3. And here, what I need to do is find some that add up to negative 10. And if I do that with this one, negative 12 and 2, I get my negative 10. So I'm going to put that over here as negative 12 and 2. And then I'm going to put those two in here, negative 12 and positive 2. Now is where I look at what's the common factor. I can divide both of these by 12, and I can divide both of these by 2. Notice that the 2 times 12 is 24. Because I put 24 in twice, I only need it one time. So by taking out common factors that multiply to make up to 24, I get rid of the extra time I put it in. So the extra time I put it in is just a trick to help me out, not an actual real supposed to be the answer. It just helps me get to the answer. So it's a method. So if I divide here, I get 2x minus 1. And if I divide here, I get 12x plus 1. And that should be perfectly fine. And I'm going to double check it. Okay, let's get it back. Make a nice box here. So 2x times 12x is 24x squared. 2x times 1 is plus 2x. Negative 1 times 12x here is negative 12x, and negative 1 times 1 is minus 1. These combine to make a negative 10x, so I do indeed have this original. Yellow highlighting to show that's correct. All right, now let's look at this one. This is a good time if you're watching this video to stop it, try to do this problem yourself, and then come back to it and see what I did. I'll give you a few seconds to do that. I'm going to start almost immediately. Okay, if you did that, and hopefully you're back now, let's see what we're going to do here. I'm going to do the same method where I do 3 x's, and I'm going to do the diagonal, the diamond, and 3 times negative 12 is negative 36, and I'm going to add up to negative 5. So to get to 36, I have the 36 and 1, and 1 would be negative, 18 and 2, 9 and 4, ooh, probably something with that, and of course I have 6 and 6. But with 9 and 4, if it's negative 9 plus 4, then I get the negative 5. So here I'll put the negative 9 and the 4, and then I'll bring them over here, negative 9, positive 4, and it doesn't matter which one because they both have 3 x's. Here I can divide by a 3, so I get x minus 3, and I get 3x plus 4. And if I multiply to get x times 3x is 3x squared. X times 4 gives me plus 4x. And here I get negative 9x, and here I get negative 12. This becomes negative 5x. So I get each of these 3 things here from the original. That means this is the correct factorization. Back there. Okay. Ooh, I don't know why it's not working here. Let's see if it does this way. Sometimes I just have to press a little differently. All right, there. So that's the correct factorization of this problem. Now let's look at some special cases. You will see a difference of 2 squares very often, like lots and lots of times. When you have a difference, meaning a subtraction, differences makes sense, but it's the math way of saying just subtract. Well, that means it's automatically the pattern of a minus b and a plus b. Notice they're not squared anymore because when you multiply it, then you get them. So watch what happens when you multiply. A times a is a squared. A times b is plus ab. Negative b times a is negative, and it doesn't matter when you multiply which one comes first. And then we get negative b squared. Look at that, where these two will go away. They cancel out. And so we get a squared minus b squared. So whenever you see an a squared minus b squared, and immediately you use that formula. Just memorize it, and you'll see it makes sense. Here in this case, my a is equal to x, and my b is equal to 5, because 25 is 5 squared. So that means I want to use, for a minus b and a plus b, I want to use an x minus a 5 and an x plus a 5. Now with 36x squared minus 1, this one's teaching 2 different things. One of them is that you can have these combined. You could write this as 6 squared x squared, but when you do, it's much more efficient afterwards to put the square outside parentheses for both of them, because that's what your a is. And then you have to recognize that a 1 is actually a 1 squared. So that means the 1 is the b. So now I'll use 6x plus 1 and 6x minus 1. And this is a reminder that it doesn't matter whether the plus or the minus is first. And if you multiply that out, you'll get 36x squared minus 1. Okay, now it stayed this big. Let's look at one where we have a number of things going on. Here, that's a 7 and an x, so this you can rewrite as 7x squared minus, well, square root of 81 is 9, and y, so it's 9y squared. And so we have 7x plus 9y and 7x minus 9y. Pretty easy once you recognize what the A and the B are. Remember that it's minus and plus. Now, notice that for all of these, you really need to know your perfect squares. So one of the things you want to do is, if you don't know them, memorize them. 1, 4 is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. You really should know them up to the 12s, absolutely, perfectly, completely. It's not all that hard to remember the next three, because 169 and 196, so that's 13 squared and 14 squared. It's really just to remember 6, 9, and 9, 6 in the switch. And of course, a 15 or a 5 is going to have a 5 at the end, so it sort of makes sense. 225 is not that hard of a number to remember. So these are not, and I don't expect most people to have it memorized, but it will help you a little bit at times. You'll be a little faster at things if you do. But you very definitely should know these cold, like barely thinking about them. You should just know them. You see the number, you know automatically it's the square of that number. You square the number, you know automatically without a calculator. You can do those. Now let's look at factoring by grouping. Factoring by grouping requires simply that you cut it in half and put it into two groups. And it means you're going to use a common factor, and then you can use a common factor again, and then you can use a common factor again. So let's look at how this works. On this one, I'm going to take the first half, and I'm going to see, ooh, they both have lots of x's, so I can take x cubed out of them. I couldn't do that for the whole thing because the 21 doesn't have an x, so that's why I'm splitting it up. And then 8 and 28, looks like 4 can go into both of those. So if I divide by that and put it out here as the common factor, I get 2x minus 4 goes into 27 times minus 7. And now over here on the second half, I'm going to do the same thing, except that I notice when I look at it, there's no x's that can be taken out. The only thing I can do is take out a 3. So that means I do have a 3, and that means it's going to be 2x minus 7. And since the 3 I'm taking out is positive, not negative, I'll do that. All right, now here there's two sticky things. One of them is that these two things in parentheses must be exactly the same. And when you do that, when they are exactly the same, that means what I'm doing is I'm taking out a common factor. Look over here. Imagine that I had 4x cubed j plus 3j. If you saw that, you would know that this j here is a common factor, and I can take it out and put it in front, j as 4x cubed plus 3. This is j. In other words, a binomial can be a common factor. It's not just a single number. It doesn't have to be a single number. All it has to be is the same exact thing. So what I'm going to do here is I'm going to take 2x minus 7. Oops, I forgot the minus. Let's get that minus there. 2x minus 7 out of, here and here, out of the 4x cubed plus the 3. And the 2x minus 7 has to be in parentheses also, because that's what it is. It's a thing together. It's a full expression there. Wow, we got a binomial. And usually I'd like to put the one with the cube first, but it really isn't material here. If I multiply this out, let's see if we get back to the original. 2x times 4x cubed, 2 times 4 is 8. That makes x to the 4th. I multiply this one, I get plus 6x. I multiply these two, I get plus 28x cubed. Multiply these two, I get negative 21. And so if I put them in order, that one's first, this one would be second. Ooh, let's check the negatives, because that was a negative here. And I recognize now, good thing I looked, because this was a negative 7. And when I multiplied it this, I needed to get a negative 28. So I'm going to erase it. So yeah, that's why it's always so worth it to double check things and look and see, did I get these? So in this case, that's a negative, so that covers the second one. Plus 6x is here, and the minus 21, I got that sign right. That means this is the correct factoring or factorization of that 4 term. Oh, no, wait. All right, now let's do one more of them here. And in this case, let's draw a line here, separate that. I am going to do the same thing, but what this one does is it shows you with a negative what's happening. Okay? So it's going to be a little different, but not much different. When I look at these two, I can take a 5 from both and x squared from both. So I get 5x squared, 5 cancels, and all the x's but 1. And here, 5x plus 2. Ooh, okay. Now, this is what I got here. I have to get the exact same thing on the other side. And I'm going to do it wrong first. I'm going to see, oh, the only thing I take out is a 1. So that means I'd have 1, negative x minus 2, but these two are not the same. Reason for that is because it's not a 1 you take out, it's a negative you take out. If you have a negative here in this spot, then that means you need to remove negative as your common factor. Even if there's nothing else, that means you do it with a negative 1. So now I have a negative 1, and the negatives cancel, which makes that x, and the negatives cancel, which makes that plus 2. And notice that now these two things are indeed the same. And that's your common factor for the last step. The last step is then to take out that common factor of x plus 2, and these two things are what's left. So I'm going to do an x times 5x squared to give me 5x cubed minus x plus 10x squared minus 2, and let's check 5x cubed minus x plus 10x minus 2. Okay, that looks good. So now on this last problem, I'll do that in a second. Why don't you try to do it yourself first? Stop the video, try to do this, and come back in about, I'll start in 3 seconds. For you, it could be 3 minutes. All right. I am going to split it in half. Aha, I see there's a negative here, which means immediately I'm going to be dividing by a negative, and it looks like the only thing I can do is a negative 1. But over here, I can take out more things. 9 goes into 27, so it looks like 9's work. And then they both have enough x's for x squared. So I have 9x squared, and that leaves an x here and a plus 3 here, and then minus 1, because that's the common factor here. And then that makes the minuses, means that this becomes an x, and that becomes a plus 3, which is good. The x plus 3 is the common factor. Now, I'm not done, because this is where your recognition in math needs to come in. You have seen this kind of thing before, and you have to recognize that this is actually a difference of 2 squares, which means you have to multiply, you have to break it down as well. You are not done factoring until you've fully factored everything. So 3x and a 1 and a 1 here means that I would do 3x minus 1 and 3x plus 1. And only now, with this being factored, is this the correct answer. So if you were on a test and you left this is the answer, you'd only get half credit. If that is just not corrected because you haven't done it all. And it's your job to recognize this. When you see two perfect squares with a minus sign between them, you know that you can factor it, and so factor it all the way. And that's what happens. That's why this is a nice variation for us to see and for us to end on. I hope this was helpful. Thank you for listening.